Expanding beyond this is not expected to answer for the closed form solution. Also, having something as involved in this, the closed form solution, is not something I'd expect on the exam. There's just a few too many steps involved. But I wanted something a little bit more involved for the mock exam so that you can see how you could expand in different ways, as well as applying each closed form, I cubed, I squared, I1. And now we're going to look at C, where we're going to compute the definite integral by taking the limit as n goes to infinity. And we're going to talk about a trick. So here, when we're computing this limit, we're taking the limit as n goes to infinity of Rn. And the trick with this is that only the terms that match the powers of n are going to survive. Every other term is going to be canceled out. So here, we look at this, r over r to the n to the 4. Here, n squared, the leading terms are just going to survive. So it's going to give us 16 over n to the 4 times n to the 4 over 4 plus zeros. Plus, and now here what we're going to get is we're going to get 48 over n cubed minus 0 times 2n cubed plus 0 over 6 for our second term, because all the other terms are going to die. And if you expanded your limit, you can determine that for yourself. Next, we're going to get 36 over n squared plus 0 equaling n squared plus 0 over 2 plus, and this is actually going to give us 0 in the end. So this is going to equal 16 over 4, because the n's, the 4's cancel. And what makes the other term 0 is all the other terms will have a power of 0 on the denominator that's greater than the power of n on the denominator that's greater than the power of n on the numerator. So when they reduce, it'll be a number over infinity, which is just 0. Plus 48 over n. Here, the n cubes are going to cancel. The 2 and the 6 are going to cancel to give us 48 over 3. Plus, here our n squares are going to cancel, and our 2 is going to cancel with the 36, or 36 over 2 plus 0, which is going to equal 4 plus 12 plus 10, 18, which is going to equal 34. And now we want to verify it using the fundamental theorem of calculus. So to verify it, we're taking and this should be 3. We're going to take the integral from 3 to 5 of x cubed minus 2x dx to x squared dx, because our original expression was, 3x squared. So this should be 3x squared dx, which gives us 4, or x to the power 4 over 4 minus x to the power 3, evaluated from x equaling 3, 5, which gives us 125 over 4 minus, not 125. 625 over 4 minus 125 subtracted 81 over 4 minus 27. Here gives us 625 minus, multiply this by 4, we get 500 over 4. Subtract here 81 over 4 minus, and here 27 minus 4 is going to, times 4 is going to be minus 108 over 4, which is 125 over 4 plus, and now 108 minus 80 is 28 minus another 1 is 27 over 4, which is going to give us 152 over 4. And if we divide by 4, we get 152, 4, we get 312, subtract 2, 6. Or no, not 152. We should get, oh, this is 32, sorry. 32, which gives us 8. So this gives us 0, so we're getting 38. So we got an answer of 38. And here it's 34, which means that there's an error by 2. I'm going to pause the video there. So I found the mistake here, and it's this division here. 48 divided by 3 is 16, not 12. So when you add them up, you're going to get 38, not 34, which we verified to be what we should be getting, 38 down here.